Now today I'm going to teach you a very powerful tool in mathematics. Extremely powerful tool. Now, suppose you had to prove that 1 plus 2 plus 3 plus 4 plus up to n is n into n plus 1 by 2. Suppose one had to prove this. That is, the sum of the first n natural numbers is n into n plus 1 by 2. Suppose we had to prove that the sum of the first n natural numbers is n into n plus 1 by 2. By some means, I've been able to obtain this result. By checking for n equal to 1, 2, etc., I've been able to get this. But now, what I want to do is, given that this is a predicted result for the sum of the first n natural numbers, I want to verify this. I want to verify that this result is true, right? Now, one of the things you could do is, you can start with n equal to 1, say for example. Then you'll have left hand side will be 1, and the right hand side would be 1 into 2 by 2, which is 1. So left hand side and right hand side are equal for n equal to 1. For n equal to 1, you'll have sum of the first natural number, which is 1, and the right hand side becomes 1 into 1 plus 1 by 2, which is 1. So good. For n equal to 1, 1 is 1, left hand side is 1, right hand side is 1. The result is good. Now, for n equal to 2, left hand, that means 2 natural numbers, 1 plus 2 then, right? 1 plus 2, left hand side would be 1 plus 2. Now let's look at the right hand side for n equal to 2. 2 into 2 plus 1 by 2, 2 into 3 by 2. Is the left hand side equal to the right hand side? Yes. 3 and 3. That means the result is true for n equal to 2. Similarly, check for n equal to 3, for example. 1 plus 2 plus 3, sum of the first 3 natural numbers. And let me look at the right hand side. Put n equal to 3, 3 into 4 by 2. Is this equal? Are these equal? This is 6, this is 6. That means for n equal to 3 also it's good. Similarly, you can check for n equal to 4, n equal to, but how long will you check? Now, if you have checked for 20,000 numbers and it turns out to be good, does it still mean that it's going to be good for all n? It still does. If you have checked for 20 million numbers and it's found to be true, if you have done this calculation and this result is found to be true, but will you still be sure that it's going to be true for all natural numbers n? 100,000 million numbers, if you have checked and this is found to be true, then also you can't say, right? Which means this result is, let's say, true for some n's that I have checked, and I have predicted that this is going to be the result. Now I want to verify it. Now, verification doesn't mean checking for 1 million, 2 million numbers, 3 million numbers, 100 million numbers, few billion numbers, and so on and so forth. That will not do the job for us. We need a smarter way of handling this. We need a smarter way of handling this. Now, this is a statement. I refer to this statement as Pn, a statement in n, in natural number n. This is a statement. I call it a statement in n, a statement in n, right? Now, what I assume is, I assume that the statement is true for some n. For some n belonging to the set of natural numbers, let me assume that this is true. That means Pn is true. Pn is a statement. Now, Pn is a statement where this is equal to this. It's only a statement in n. It's a statement in natural number n. I'm assuming that Pn is true for some natural number n. I'm assuming, right? Now, let me see if Pn is true. Let me check. Let's check if the statement is true. This statement is true if we increase n by 1. That is for n plus 1. Let me see if this statement is true for n plus 1. I'm assuming that this statement is true for n. Pn is true. Let me see if Pn plus 1 is true. Given that Pn is true, or assuming that Pn is true, let me see if that is Pn plus 1 is true or not. True or not. This is a check that I'm going to perform. Given that Pn is true, I want to see if Pn plus 1 is true. Now, what is Pn plus 1? Pn plus 1 means replacing n by n plus 1. Replacing n by n plus 1. If Pn is this statement, then Pn plus 1 means replacing n by n plus 1. That's the statement Pn plus 1. Let me see that if Pn is true, whether Pn being true causes Pn plus 1 to be true or not. Alright. Now, what is the statement Pn plus 1? The statement Pn plus 1 is now, I'll have sum of the first n plus 1 natural numbers. Right? Pn plus 1 is 1 plus 2 plus 3 plus 4 plus n plus n plus 1. That's the left hand side of the statement of Pn. And whether this is equal to n replaced by n plus 1, so this will become n plus 1. If n is replaced by n plus 1, this will become n plus 1. N replaced by n plus 1, this will become n plus 1 plus 1, which is n plus 2. So this is n plus 1 into n plus 2, yes or no? Right? So, replacing n by n plus 1, whether I still get the statement true or not. That's a check, that's a verification that I'm going to perform. So that means whether this is equal to replacing n by n plus 1. That means n plus 1 into n plus 2 by 2 or not. We have to see if this statement is true or not. Right? Given that Pn is true means I'm assuming that this is true. I'm checking whether on increasing n by 1, this statement is true or not. That means whether Pn plus 1 is true or not. That means whether 1 plus 2 plus 3 plus 4 plus n plus 1 is equal to replacing n by n plus 1, because in left hand side also have replaced n by n plus 1. Then before n plus 1 you would have encountered a n. So this should then be equal to n plus 1 into n plus 2 by 2. Let's see if that is true or not. Got me? Now, the left hand side of this statement, Pn plus 1. The left hand side of this statement referred to as Pn plus 1 is 1 plus 2 plus 3 plus n plus n plus 1. That's the left hand side of the statement. Right? If I can show that this is equal to this, then this statement is true. Given that Pn is true, given that this is true. Now, realize that 1 plus 2 plus 3 plus up to n is anyways equal to n into n plus 1 by 2, because I have assumed this statement to be true. I have assumed the statement for n to be true. That means 1 plus 2 plus 3 plus n is indeed equal to n into n plus 1 by 2, because I have assumed Pn to be true. Yes or no? Confused? No? So, since I have assumed Pn to be true, this must be equal to n into n plus 1 by 2. And then plus n plus 1. Yes or no? Yes or no? My objective is to be able to show that Pn plus 1 is true. That means this sum up to n plus 1 is this. That means Pn plus 1 is also a true statement. Now, this, what I do is, from these two numbers, I take n plus 1 by 2 common. From these two numbers, I take n plus 1 by 2 common. So, n plus 1 by 2, if I take common, then this will be like n, and this will be like 2. This will be like 2, isn't it? If I took n plus 1 by 2 common, isn't it? Then 2 and 2 cancels, and this would be n plus 1, isn't it? Do you all realize what I've done here? Huh? So, which is like n plus 1 into n plus 2 by 2. That means this is true, yes or no? The statement is true for n plus 1. The statement is true for n plus 1, yes or no? See, this was the statement for n plus 1, and I have been able to show that the statement is true for n plus 1, given that the statement is true for n. That means if I assume that it's true for n, it has to be true for n plus 1. If it is true for London, it will be true for London plus 1. And now that it is true for London plus 1, it must also be true for London plus 2. Because every time I increase n by 1, the statement is true. This is what it means. If it is true for n, it turns out to be true for n plus 1. And from similar logic, if it is true for n plus 1, it has to be true for n plus 2. If it is true for n plus 2, it will then be true for n plus 3. If it is true for n plus 3, it will be true for n plus 4, and so on and so forth. Yes or no? Right? This is how the logic flows. This is the flow of logic. All of you understand this? Which means, see, did I found the result to be true for n equal to 1? P1 is true. N equal to 1 is P1. The result for n equal to 1 is P1. P1 is true. But what I have established is, if Pn is true, Pn plus 1 will also be true. That means for n equal to 2, it must be true. P1 is true means P2 must also be true. That means the statement for n equal to 2 must be true. And if P2 is true, it means P3 is true. Because if Pn is true, Pn plus 1 is true. If P3 is true, that means P4 must be true. Why? Because if Pn is true, Pn plus 1 is true, and so on and so forth. This would just eventually go on till the very end, and it will be true for all n. Yes or no? So what did I do? I assumed this result to be true for n. And the truth of that statement I referred to as Pn. Given that Pn is true, I established that Pn plus 1 will also be true with this manipulation. Right? And therefore, I arrived at a simple logic. Pn being true implies Pn plus 1 is true. Now I checked for n equal to 1. And I found, because I can't keep checking for all n, but I found that for n equal to 1, it's true. I can check for 1n. But what this logic says is that if P1 is true, P2 is true. And then therefore, if P2 is true, P3 is true. If P3 is true, P4 is true. If P4 is true, P5 is true. And therefore, it's true for all n. Yes or no? This principle is called the principle of mathematical induction. This is the principle of mathematical induction. Refer to the sheet. Okay. Start working on the problems. One I just solved for you. Start with true 2. In all these cases, check for, let's say, n equal to 1, and you find the result to be true, say. And then assume that Pn is true, the given statement is true. Given the truth of Pn, establish that Pn plus 1 must be true. And once you have this logic, if it's true for n, it turns out to be true for n plus 1. Then if P1 is true, P2 must be true. And then P2 is true would imply P3 is true. If P3 is true, P4 is true. And then it will turn out to be true for all n. And you can inductively obtain this result. Right? So start working from problem 2 onwards, all of you, neatly and cleanly. And I'll keep attending to you. Stand by.